The view that machines cannot give rise to surprise is due, I believe, to a fallacy. This is the assumption that as soon as a fact is presented to a mind, all the consequences of that fact spring into the mind simultaneously with it. This is Alan Turing, and he was talking to mathematicians, to philosophers back in the late 40s, early 50s, about how computers, about how artificial intelligence can do things that we would find surprising, despite how much we think we understand these systems and what computing and abstraction is. It's not the case. Well, why am I starting off with this? I'm sure you read the thumbnail. This is about, the future of prompting. What does it mean to orchestrate AI, this future of AI? How do you be relevant in this world? Things like that. But the goal of today's video is to do three things. One, to show that you need to understand AI is the next compiler. It is a new abstraction language that we are using. And if you don't understand what that is, that's okay. I'm going to teach you this. And if you do understand what that is and you disagree, hopefully I'll convince you the opposite by the end of this video. Also, the second thing is that you'll come away understanding more about the future, understanding that companies themselves, people, your own job, all depend on you understanding this fact. Making money, or even if you're an investor and you're investing money in these companies, is going to be dependent on whether you understand this. 95% of AI initiatives are currently failing according to an MIT study. And if you want less, focus on this, there's a lot of people looking at this bubble, and I fully 100% believe there is a massive AI bubble. I love a lot of generative artificial intelligence, machine learning, things like that, but we are in a bubble much like the internet. By 2001, the internet had, I believe, 500 million users. We still barely have 300 to 400 million users of AI. Generative AI, at least that is. So we're still in the early days, but that means we also have the early growing pains. And I 100% believe we are going to see that. However, how to navigate this, how to get through it, you have to have axioms. If you constantly feel like you're behind or you're not catching up, it's because you're not operating on fundamental truths. Everyone that's saying this is disruptive is true, but it's only disruptive and you're only going to feel like you're falling behind if you don't understand the simple basics of how this technology is being used. And believe me, whether you're a programmer or not, you can understand this, and I will teach you this. If you are a programmer, you're still going to get a massive amount about this video because I'm showing you how I create data pipelines and how I use AI in my daily process. Now, who am I? Why should you listen to me? For those of you who are watching and you do know me, awesome, cool. For those of you who don't, I'm Jake. I was in the US Marine Corps for quite a little while. I was in cryptography, avionics, worked on F-18s, a little bit on F-35s here or there. That's actually from my squadron, 242, Mors Extenebris, Darkness. Sorry for my Marine friends watching this, it's cringe. But after the Marine Corps, dove into political science, little undergrad degree. I was doing kind of AI alongside of that as well. I was using it in papers and aspects and doing studies on how it affected the papers, which expanded into my post-grad research at the University of Edinburgh. I actually submitted a big thesis on AI and psychometric data pipelines, bunch of nerdy stuff, focus stuff, really cool if you're into it. I can put a link in the description if you want to check it out. And I currently work a lot with the neuropolitics on kind of AI and how it's affecting governance and politics and all that good jazz. But professionally, I get paid way too much, not way too much actually, I could always charge more, but to essentially do these trainings, these workshops on what the future of AI is, how you should implement it, how do you not spend too much money on it, and actually build pipelines for big companies. I've worked and done workshops for executives. I'm working with the British Council. I'm on a project for the European Union. I've done some serious stuff with some serious companies. So I'm telling you, this isn't coming from, oh, this is what I think. I am on the ground building these things, doing these things, seeing the issues every single day, 14 hours a day. So hopefully that's enough to get you in there, but let's dive into the meat of it. What am I going to teach you? How am I going to teach you this? Now, I'm sure all of you have heard prompt engineering or what prompting is. You may have heard things about chain of prompting or prompting the AI. I want to clear some air. I made a video a bit ago about what prompt engineering is, and I think there's a lot of disconnects. I saw a video of some girl. She was saying that prompt engineering isn't real. It doesn't exist. Just putting a bunch of words together means you're a good communicator, not a programmer or an engineer. And there's some truth for that. There's some people that say they're prompt engineering, but they're not. And to a certain extent, I don't know, that sounds more like gatekeeping. I think if you're really good at putting together words and systems and communications. There is a lot of programming logic behind that. But despite that, there is also truth to the other side of it, which is there's advanced prompt engineering. Again, don't worry if you don't understand what you're looking at with prompting or anything like that. This is just purely to show you an aspect here. So actual prompt engineering involves kind of what you're seeing on the screen here. These are all prompt templates, prompt pooling of specific questions. Again, this is all from my thesis if you want to learn more about it. Essentially, what I did is I took a whole bunch of psychometric scales. So think of a psychometric scale as a personality test. I took a personality test and you get a personality score or a kind of prediction of what you might do in certain situations. These are scales or questions, question 1, question 2, question 3, of a test that was used back in the 50s to figure out how fascist someone was. It's called right-wing authoritarianism. There's also another scale for left-wing authoritarianism. So you take these, you say whether you agree or disagree with a statement, like life imprisonment is justified for certain crimes. Then some math happens in the back end, and it says, this is how likely you are or are not to be an authoritarian. I wanted to test what the AI would respond to on these scales. But in order to do that, if I just copy and pasted the scale into ChatGPT, two things are big there. One, it's a little unpredictable. It's a little hard to repeat that 10,000 times. Copying and pasting, copying and pasting, copying and pasting. Two, if I put the whole scale in there, there's actually a lot of studies and research, which should be popping up here, that show that when the AI sees it's taking a personality test, it will start to answer what it thinks would be favorable. And that's actually seen in humans too. It's a favorability bias. I wanted to be able to separate each question and just ask it to the model individually. On top of that, that allows me to really test individually across every single prompt and every single question if there's any issues or weirdness or variability that maybe could point us into the direction of some sort of insights. Now, from those things you saw up there, I actually am calling upon a final prompt. So when you send a prompt to the chatbot, when you type in a chat box to an AI, in the background, you're seeing maybe something that looks like this. It's saying what model you need to use. In this case, I'm calling Grok. In this one, I'm using Claude. I could be doing the ChatGPT one up here from OpenAI. It's saying who the user is, what content it is. So you have a question and you ask, hey, AI, can I do this? It sends that prompt to the model and it tells you what it should generate based on tokens and temperature. Again, I don't want to go too deep into this. If you understand what those are awesome. If not, I'm going to make more videos diving deeper into these concepts. You just want to throw this data at you so you understand it. So basically, I'm sending something called final prompt. Now, final prompt itself is actually being focused by style prompt. Style prompt is being pulled from whatever sort of prompt style and keys, which are being pulled from this big list here. What that means is I am using Python to automate a prompting process in a certain order and a certain way. I am engineering the prompts to be given to the model in a specific order or way to create reproducibility. At a huge, large scale, this is one form of prompt engineering. Now, I get it. If I'm losing you or this is too much, don't worry. I'm about to explain what this is in much more simpler terms. Again, I built this entire pipeline myself. This is kind of brand new. I didn't really use anyone to kind of help me build off of this. There isn't other pipelines I saw that were like this. This is very bespoke. It's on my GitHub. If you are a programmer, the link will be down below. I did it in a Python notebook format, so it's easy to kind of step through, show you how to use it and everything. Let's dive into something simpler. I just wanted to throw all that at you so you can, see where we're going, but let's scale it back. How do we do all of that? What does all of that mean and why is it important? Well, AI using it well, or using it like how I just use it, is much like a smart Mad Libs game. Mad Libs, for those of you who don't know, it's like a book and it gives you a bunch of sentences and you get to write in or type in adjectives or adverbs to make your own sentences. So the blank dog ran blank to the blank, and it would specifically say adjective, adverb, place. Now, the AI, or the way I'm using AI in that specific pipeline, or way you would want to use it in other pipelines, again, this is the idea, we're teaching the logic, the abstractness here, is that you could do the same thing. You can have a prompt where it says, you are a blank persona, please rate this statement, question. Question and persona can be stored elsewhere and added in. You're automating the introduction of that prompt, or you have a prompt structure and you're changing it in. Again, you don't have to do code. You can do this with a normal chatbot. What I mean by that is, if you log into ChatGPT or Gemini or Google or any of the other ones, let's say you gave it a list that you had yourself. So you decided which words you wanted to use for that sentence. And again, this task isn't what you'd be doing this task for. This is to help you understand this can be applied to a plethora of tasks. But let's say I have a list, or this could be a document you're pulling from, or a code base of adjectives, of adverbs, quietly, drifting, and I labeled them myself and I wanted these words. So we're making sure the data it's getting is mine. You can then say, create a bunch of sentences using that structure for this sentence. And what it's going to do is, it's going to pull from your list and create a bunch of sentences. The restless dog ran swiftly to the forest. The timid cat crept quietly into the attic. Now, again, this is a simpler version of it, but the idea here is you're controlling the output based on what you directly want as input. And you can start building on that abstraction, but it's all natural language. Again, this is going to come important as we're slowly going on. We're building up abstractness here, but you can see it works just as fine within a chat environment. That's exactly what we're doing inside the code I'm showing you here. I am simply, what you just saw, doing Mad Libs. I am giving it a prompt or a Python code or some code to do. I am either using the code itself to input in the prompts, or the AI is listening to those prompts programmatically. The reason this is important is this gives you templates to control the output. You can now send automated prompts to an agent or an AI. Again, agent's a big word. There's a lot of arguments about it, but take it with a grain of salt. So it could be a persona, and that persona gets swapped out with my data library. It could be a question, and it gets swapped out with all of my questions I want. And the personas could be very optimistic person, very pessimistic person. It could be tone for writing, things like that. The questions could be tomorrow will be better than today, and the optimistic person or pessimistic person will give a different output. Again, tone, this could be swapped out with the ability of that agent. Sometimes people will say, you're now an expert in coding. You're now an expert in this type of coding. I think it's connecting for those of you who are seeing it there, but let's continue going on. Every single prompt you give an AI should have fixed parts, which are the instructions, and variable parts, the things that are changing. The fixed parts are going to be, you are a blank, please rate from this, provide your answer like this. The variable parts are going to change every time. Who they are, what they are, how many questions they ask. Further, you can combine each of these to create more unique prompts. You are this persona, and I want you to rate this statement in this scale. You can swip and swap those and start having the agents do very specific things in a very good way, rather than having to chat through it and create the prompts. They're happening automatically. And this is important because of what I said earlier. AI is a compiler. Now, for those of you unsure what compiler is, or for those of you who do know what it is and are still disconnecting on what I mean by that, look at this. Programming languages are the way we use symbolic representation or mathematic representation to essentially map physical happenings. There is hardware programming languages. So you have physical switches turning on and off. You have machine languages, your zeros, your ones, you hear about binary, things like that. But then we would condense those. Like hardboard switching back and forth, we represented processes of that with machine language. Then we represented and condensed those processes with assembly language. Then we kind of argued and talked about kind of compilers and compiling those processes, as in 1,000 instruction lines, 1,000 lines of code does this one thing and we keep using it over and over again. Well, we can turn that process and automate it into one line of code. And we kept doing this with every layer of code until you get to these higher level languages like Python or Java. My argument is that AI is now creating another tier to that pyramid. It's not exactly doing that right now, but it's going to be. This assembly line of using logical outputs and ensuring their accuracy is building off of itself. It's continuing up this ladder. And I'm sending information to an AI so that it comes back with a certain output. And the AI is doing computations or processes that previously I had to code manually. Now it's automating some of that coding process. Again, I'm not saying it's replacing code. I'm saying we're adding an abstraction layer to it. Is there going to be as many Python programmers? I don't think so. In the same way that there's not as many Fortran or lower level language programmers, but they are equally important. You can get jobs at NASA still for those languages. Those low level languages conceptually are still important. Building new ways in which to do hardware parallelization is actually, I would argue, more important now. The majority of jobs or focuses or learning is going to be at this higher level, and we're already witnessing this shift. The problem is we are still building the layer of that languages, the processes, the continuancing of that scale, scaling up how we call these models, how we ad lib and send them. The processes that I'm showing you here need to be organized more. They need to be sent more. And what does that look like? This is a very simple version. There's a lot of other tools out there like Semantic Kernel, Crew AI, and just every big AI company is doing this on the back end. This isn't new necessarily. I'm not just out at the front completely. There's people who have been doing this process, or at least understand this process, for quite a few years now. But the idea here is the template, your natural words, the variables, your natural variables or numbers, are being put into a prompt. And they're doing it in a structured way that sends it to the AI and expects a very specific output. So that now the processes between, this output or this answer that required me to, code a whole bunch of Python here or code a pipeline, I now no longer have to do because I can automate parts of it. And we're continuously doing that with different agents, different LLMs, different work processes. This is also happening at the larger scale, at the business level, the workflow level. We're condensing variables of workflow, variables of templates, business templates, and we're creating an automation of that as well, which is where this worry of job replacement comes from. And I'm not going to comment on that in this video, but it's a valid worry in many ways. But this process is what we're automating and compiling with the AI. With traditional programming, I had to code every single step for every single edge case. If the persona is conservative and the question is taxes, then you have to return this programmatic question for every single possible output. But now we can ask the AI, here is this and this, use context to compile and get the best possible output related to that input. That allows us to skip a lot of steps or automate certain steps that would have taken hundreds and hundreds of lines of code to do and compile it into one line of code. Now, I was going to actually do this entire notebook in this video where I dive into kind of the orchestration techniques, the more advanced techniques around this, but I realized that was a lot for a single video, and I really liked how that was ending. So what I'm going to do is a part 2 of this video where I dive into the next iteration. What does the next 10 years look like following those fundamentals? Pretty much where we're taking those templates, these Mad Lib templates, and turning them into actual orchestration, computational orchestration, turning those templates into actual agentic workflows. Again, I'm using code here, but this can be used at any abstraction level, whether it's business operations, investment, startup creation, education. It's common across all of them. But to give a little sneak peek and kind of this aspect here, I wanted to dive into the fact that you'll notice a pattern. Whether you're just interacting with ChatGPT, you're using something more advanced like Claude Code, you're using something even more advanced or building something with semantic kernel or Crew AI, you're using the same 4 concepts here. We're doing the same 4 things. You're defining a role or a persona or a context and tone. You're setting structure. You're adding a validation level, and you're handling errors. So what do I mean by that? This is common to all programming for the last 100 years. In ChatGPT, you're telling it to act as an analyst, and you're saying what type of format or what its output should be, maybe. And you're manually checking what that output is. Ooh, I like that. Ooh, change your tone here. Ooh, I don't really do this. And trying again manually. With Claude Code or any of these more advanced tools, you're actually automating some of these processes or condensing these personas into files or databases or even functions. You're using some sort of template or schema to validate those processes or to conduct those processes. And then you're creating some sort of automatic validation process, some sort of checking or built-in validation. Some semantic kernel and Crew AI are actually doing this on their own process. And then some sort of retrying aspect. Each of these are, in the coding level, have their own version of it. These are defined schemas, processes that are going to stay the same because they've stayed the same for 100 years across multiple programming languages and into the AI age. Again, I'll do a whole other video on that, but I just wanted to kind of talk about that. I hope this kind of answers a lot of questions. If it didn't, please ask all of those questions. This is extremely important to me. And yeah, that is it for today's video. Hopefully this taught you some good stuff. And again, ask the questions. That's all I need. Have a good day.